Hello students, now it's the quantum number. Quantum number is what? The complete address of the electron. These are of four type as you are seeing that I have done on the board. N, L, M and S. N is the principal quantum number. It tells the energy level. If N is equal to 1, then it is K shell. If N is equal to 2, L, M, N and so on. Azimuthal quantum number is represented by L. It is also known as subsidiary quantum number. It tells the shape of the orbitals and its mathematical value comes from 0 to n minus 1. This is important. And whereas magnetic quantum number represented by M, and it tells the behavior of electron in the magnetic field, and its value depend upon the L, and value of L will depend upon the value of N, and it is given by minus L to plus L. Now see that I am just going to take one example. If N is equal to 2, then L will be what? 0 to n minus 1, means that L may be 0, may be 1. If I will take, I am just taking collectively, if I will take N is equal to 4, then L is equal to 1. L is equal to maybe 0, L is equal to 1, L is equal to 2, L is equal to 3. Because of that, mathematical value come from 0 to n minus 1. And if L is 0, then it is s orbital. And s is spherical and number of electron in s the 2. Whatsoever, it doesn't matter, 2s, 3s, 4s, 100s, no matter. If L is equal to coming 1, it is p orbital, and p orbital is having pyramidal shape, and its electron is coming 6, dumbbell shape. And if L is equal to 2, then it stands for d orbital, and d orbital is double dumbbell, and number of electron in d subshell is 10. And if L is equal to stand for 3, then it comes to you f orbital. F is diffuse shape, not final shape or leaf like, and number of electrons are coming 14. Now I'll take one example and explain you one more thing. If n is equal to 2, then if n is equal to 2, then maybe L is equal to 0 and maybe L is equal to 1. If n, so first case is what? N is equal to 2, L is equal to 0, then it is 2s orbital. And if n is equal to 2, L is equal to 1, then it is the 2p orbital. Now come on the next page and exploring and coming up to the magnetic quantum number. Yes, dear students, now one more example of the quantum number. If n is equal to 2, it may be L is equal to 0 or 1. And then m value is what? Minus L to plus L. Minus 1, 0 and plus 1. One case n is equal to 0, n is equal to 2, L is equal to 0. Then m is equal to also coming 0 and it is a 2s. And 2s orbital, 2 electrons are present. One is positive spin, one is negative spin. Positive go the clockwise and negative go the anti-clockwise. Another case, if n is equal to 2, then L is equal to maybe 1. M is equal to minus 1. When m is equal to coming minus 1, it may be 2px, it may be 2py. And n is equal to 2, L is equal to 1, m is equal to maybe plus 1, it may be 2py, whatsoever you like. You can like also 2px also. Then third case is that if n is equal to 2, L is equal to 1, m is equal to 0, then 0 always stand for 2pz. That's why the 2p orbital is having 6 electrons and they are coming in the 3 orbitals, 2px, 2py and 2pz. And px stand for this one, py stand for this one, and pz is always head to head. I hope so that you understand now the quantum numbers. And one more interesting thing, if n is equal to 5, then L is equal to what? 0, 1, 2, 3, 4. So L go for 0s, 1p, 2d, 3f and 4 stand for the G. It can be asked on the search is going on the G. So you take care of this question also, and so many questions and very interesting and easy topic, my dear students. Quantum number. In the next class we will do the Hinsberg uncertainty principle, n plus l rule and Pauli exclusion rule. Till then, goodbye. Bye bye.